At last, the last video, let's see how can we read information from input pins. We have access to two buttons in our board. Let's go to the user manual, and we have here two push buttons, a reset and a user. We're going to use the button 1, the user one, and it's under the GPIO A pin 0. It's going to be your blue button on your board. Alright, and if I recall this GPIO, what we're doing is we're going to parameterize these registers so we can have this pin as an input coming here up to your Schmidt trigger, and we might need to parameterize this pull up and pull down. We'll see it in a minute what we need to do. Alright, how do I do that? So notice that it's pretty much similar. I know that it's in a different peripheral, it's no longer on D, so I need to call this function again, and I'm going to call this function. And now I am enabling the pin A. I could use the same structure. The only problem by using the same structure here is that if I parameterize these, like one of them, and I don't change, I forget to change, you might change the behavior of your registers. So we're going to create, and to make it also easier to understand what's going on, let's create a different structure here, and now I'm going to call it's the struction GPIO button. This is going to be a structure that I'm going to use for my button. I go here and let's parameterize that one. So we have our mode. We'll see in a minute. Let's see right now what we need. So our mode, it's going to be open declaration mode. We have GPIO in. It's going to be an input pin, main input pin. Alright, sorry, copy this one. Structure GPIO button, and I don't need output type. It's not an output pin. Which pin do I want? It's going to be the 0. GPIO 0. Let's create a macro here, and I'm going to call button 0, and this one is defined on GPIO pin 0. Alright, copy that button, go back here and pass it. GPIO button, pull up and pull down resistor. I'm going to comment this one for now. We'll get there in a minute. Let's go over the last one, which is the speed of the bus for that peripheral. And we're going to use the same speed here, the 50 megahertz. Alright, let's go over the pull down and pull up resistor. And for that, let's see if the board, if we look at the board, the user manual, if we go to the beginning, we see that the LEDs, which are going to be here between, they're going to be these guys over here, this one, and this one. They have some electronics around. Let's see if the manufacturer of this board, if they put already those pull up and pull downs resistors. So let's go back to our schematics and let's find those. Here you go, this one, those buttons and LEDs. Let me rotate these, rotate view clockwise, couple more zoom. Alright, we have here our LEDs and resistors connected to those pins, and on the top we have our button. We are using the user button, and notice that the board has already some logic, some pull down. This is a pull down resistor, so I don't need to parameterize that pull up and pull down resistor because the board already has. And the button here has a capacitor, so you can have a filter because of the jitter of when you press a mechanical button. And alright, so that means that we don't need to do this this pull up, pull down resistor. And now all I need to do is to call again this GPIO init function, and I have port A, and instead of being my structure LED, it's my button. Let's compile to see if everything is fine, if I'm not making any mistake. Okay, everything is good. Now all I need to do is to start reading information. How do I do that? Let's go to the .h, let's go to the end of the file and see the functions that we have available. We have all these functions. We're going to use the read input data. Let's do this one. This one is going to, let me hover again, and reads the specific GPIO and returns the data port value. So let's do that one. I'm going to copy this function, go to main, and it returns a value. So we are in C. I need to program or declare that variable over here. It's an unsigned int 32. Was it 32? I forgot. 16. All right, 16 value. So don't forget that even if you can declare these in the middle of your code, that's just a particular thing of the development environment, because C++ allows you to do that, but C, you need to declare the variables at the beginning of your function. So I'm going to just keep it like this, value, read, and I'm going to read the values from GPIO 8. Now I want to know what am I reading when I press, when I don't press. So let's do a small test over here. I'm going to run the code, compile the code, deploy the code, and see what happens to that value when I press the button. So if I go to variables, the value is already there, and I'm already reading something, which I don't know if it's good yet because I didn't parameterize the clocks. So let's do a couple of, actually, let's go down on your code and put a big breakpoint on your value. And if I press resume, the code is going to run up to that point, the value. And now I do a step over and I can see the value 41024, which, let's see a better representation of that. Let me bring the calculator. Let me write that value 41024, and in ENCE. All right, let's bring our notepad here and let's write down that ENCE value. So I have A040. That's when I'm not pressing. So not press. Cool. And this is in ENCE, so we already know that this is in ENCE. And now I'm going to resume, and it's going to stop again on that value. And I'm going to press the button, the blue button, give one step, and now I'm reading a different value. I'm just adding one, so I'm going to read A041. So when I'm pressing, I am reading. All right, great. So all I need to do on my code here, let's stop. All I need to do is to read that value, and let's now turn on, for example, the one of the other LEDs. Let's do the blue LED is going to turn based on the button, and now I can go here and compare my value, and if it's equal to 0, I'm going to turn on the LED, and I'm going to use the blue LED. Don't forget to go to your GPIO and parameterize also the blue LED blue. I'm actually going to do all of them so I don't forget, and now I can use them without having problems. Sorry, let's go here. So I have all of them declared. Perfect. Now I go here and I have my beat reset, else my blue LED is going to be set. All right, let's deploy the code inside of your board. Let's make sure that you remove the breakpoint. Everything is fine. I press, and now if I press the button, you'll have the blue LED changing according to the button. Let's clean our code a little bit here, making it a little bit more user-friendly. So what can we do here? Notice that I'm doing a bunch of instructions inside of my main function. It becomes hard to follow your main. Normally what we do is we're going to put this inside of functions. So anything related with my LEDs, I'm going to take it out of here. I'm going to declare a function called void init LEDs. And I'm going to paste all the code there. Because the structure is a global variable, I am good to do it like this. I don't have any problems. And the same thing for the buttons. I'm going to have a void init and call buttons. Let's go like this. And here I'm going to copy the rest of the code related with, we get back here, related with your buttons. Here you go. All right. And now all I need to do on my main code is to call those functions. So I have my init LEDs and my init LEDs and my init buttons. And it becomes easier to follow your main code because I initialize my LEDs, initialize the buttons, and then I do the rest of the code. And that's pretty much it. Compile, see if everything is good. And resume, and everything should be working just fine.